Canceling is something we do when we are multiplying fractions, which helps us to multiply using smaller numbers and can make the problem easier. It can also make it so that we don't have to reduce the fraction at the end to give our most simplified answer. Let's look at this question, 4/7 times 7/9, and try doing it the usual way without canceling. 4 times 7 is 28, and 7 times 9 is 63. This fraction can be reduced. The top and the bottom have a common factor of 7. So if I divide both top and bottom by 7, I get 4/9 as my answer. Now let's try doing the same question again with canceling. Over here we have the same question, and we can see that there is a 7 on the top and a 7 on the bottom. Because both top and bottom have a 7, we can cancel. We're dividing the bottom by 7, and that gives us a 1. And we're dividing the top by a 7, and that gives us a 1. When we do this, we put a line through the number we are canceling so that we can remember we don't have that number there anymore. The 7s have been replaced by 1s. It doesn't matter that the 7 is on top is not directly above the 7 on the bottom. They don't have to be in the same fraction. The rule is just that one has to be on the top and the other on the bottom. Now I have the fraction 4/1 times 1/9. And when I multiply, 4 times 1 is 4, 1 times 9 is 9, and I have my final answer. Because I canceled as much as I could, this answer does not have to be reduced the way I did the first time. Both methods are very good for multiplying fractions, so it can really be a matter of choice. Does the student like canceling? If the student does, then they do it this way. But if you choose to do it this way, or if you don't notice the canceling opportunity, you can still get the right answer. You just have an extra step to do at the end when you reduce the fraction. Let's try this one. 3/5 times 2/3. 3 times 2 is 6. 5 times 3 is 15. But 6 and 15 have a common factor of 3. So I divide both top and bottom by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. My final answer is 2/5. Now when I do the same question with canceling, I see a 3 on the top, a 3 on the bottom. I cancel both of them. I replace them both with 1s, because what I'm really doing is I am dividing each of them by 3, their common factor. Now I have 1 times 2 on the top, and 5 times 1 on the bottom. I have the answer 2/5. It is the same answer. Canceling allowed me to get the correct answer without having to reduce the fraction at the end. Here are some more examples of canceling. In this case, we don't have the same number on the top and the bottom to cancel. Instead, we have two different numbers that share a common factor. So instead of having a 2 on the top and a 2 on the bottom, canceling them both into 1s, this time I have a 2 on the top and an 8 on the bottom, and they have a common factor of 2. So when I'm canceling, I can divide a 2 from each of those. 2 divided by 2 is 1, and 8 divided by 2 is 4. Now, I can't see any other canceling opportunities, so I'm going to do my multiplication. 1 times 3 is equal to 3. 5 times 4 is equal to 20. I have my final answer, 3/20, which cannot be further reduced. So this means you don't have to have the same number on the top and on the bottom when you're canceling. You just have to have a number on the top and one on the bottom that share a common factor. Let's try another one like that. Over here we have 3/4 times 8/11. The 4 and the 8 share a common factor of 4. And one is on the top while the other is on the bottom, so we can cancel. 4 divided by 4 is 1, and 8 divided by 4 is 2. Now I multiply. 3 times 2 is 6, and 1 times 11 is 11. I have my final answer, which cannot be reduced any further. Here's one that's a little bit more complicated, because the 3 and the 15 have a common factor of 3, while the 14 and the 7 have a common factor of 7. Cancelling the 3's first, 3 divided by 3 is 1, 15 divided by 3 is 5, 7 divided by 7 is 1, and 14 divided by 7 is 2. I end up with the top 1 times 2, and the bottom 1 times 5. I have my final answer 2/5, which cannot be reduced further. And this shows that sometimes you have two cancelling opportunities in the same multiplication of fractions. Over here, the 9 and the 3 share a common factor of 3, so dividing both of them by 3, I get 1 on the bottom and 3 on the top. The 2 and the 10 share a common factor of 2. Dividing both of them by 2, I get a 5 on the bottom and a 1 on the top. And now my multiplication is 3 times 1 on the top, 5 times 1 on the bottom. I have a final answer of 3/5, which cannot be reduced further. When we multiply fractions, we can multiply more than two fractions at once. And when we're cancelling while multiplying fractions, we can do that too while multiplying more than two fractions at once. Here in the top, we have 2/5 times 1/3 times 3/4. We look for things that will cancel, and we see that the 3 on the bottom and the 3 on the top can be cancelled. So I'm dividing both of them by 3, and that leaves 1 in each case. We also have a 2 on the top and a 4 on the bottom, and they share a common factor of 2. So we can cancel out the 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. I can't see any other cancelling opportunities, so now it's time to do my multiplication. 1 times 1 times 1 equals 1. 5 times 1 times 2 equals 10. I have my final answer, and it cannot be simplified further. The second example has 4 fractions. I see a 3 on the top and a 3 on the bottom, so I'm cancelling them, leaving 1's. And I see a 2 on the top and the 2 on the bottom. I'm cancelling them, again leaving 1's. Now, my numerators say 1 times 1 times 1 times 1, which is equal to 1. And the denominators say 1 times 1 times 5 times 7, which is equal to 35. 1/35 is my final answer, and it cannot be simplified further. The last example has 5 fractions. I see a 2 on the bottom, which I can cancel with a 2 on the top, and those leave 1's. I see another 2 on the bottom and another 2 on the top. They can be cancelled as well, leaving 1's. Now I no longer see any cancelling opportunities, so my numerators say 1 times 5 times 1 times 1 times 1, which all equals 5. And my bottom says 1 times 6 times 3 times 3 times 1. And these numbers are a little bigger, so I better take my time and be careful. 1 times 6 is 6. 6 times 3 is 18. 18 times 3 is 54. And 54 times 1 is 54. 5/54 is my final answer, and it cannot be simplified any further. The next part of this video will show another example where we have fractions with larger numbers.